is going to be talking to the browser. And an onload event. So when this thing's actually loaded, we do something pretty silly in this case, and just call onModule load, which just is going to say, hey, the native client module is loaded. Nothing special there. The last thing we need to do is set the NEXTs property of this embed tag. And the reason behind that is because of this bug, for one, and also because if you're compiling a native client module for different architectures, it's impossible to determine what architecture it's being run on inside of the browser. So in JavaScript, there's no way to determine if you're on a 32-bit machine or 64-bit machine. So we actually bake this into Chrome as a feature. Well, it's going to change a little bit, but you can see that I've compiled a different module for each of these architectures, and that's all that's going on there. So calculator. The very first thing we're going to do is write the UI for this, and the UI is just going to be C++. It's going to be JavaScript. And that's going to talk to the Pepper layer. The Pepper layer is the one that's going to be communicating to the native client module and the plugin itself. Inside of that, just to recap, is the native client sandbox. This is running our untrusted C++ code that the developer has written. And that's the native client module. So here is the sort of JavaScript of our calculator. And here's the reminder of where we are sort of in this stack. So we're just going to add some HTML and CSS and JavaScript. We'll create a start calculate method. Nothing too special there. And as you can imagine, it's going to take an input from this calculator input field, this just a normal text field. And so we're going to just create a postfix expression based on what the user has inputted in our calculator. There's a bunch of code that does that processing, just creates a postfix expression out of that input field. The reason I'm doing this in JavaScript is because it's a lot easier in JavaScript. All this manipulation in C++ would be a little bit more difficult. So, and there's no reason. JavaScript is extremely capable of doing something like this. So that is the parse expression function there. But the important part of this little section here is the calculate module, right? So we're creating this calculator object, which is our embed tag. It's just a DOM reference. Calling application.module. And there's this CSALT library is part of this bridging layer. So this is going to be a reference to our native client module in JavaScript. And the first thing we do when we try to execute maybe an expression, a calculator expression in this application, is that it's going to try to call the calculator module.calculate. It's going to pass it our expression that the user's input and call a callback function, the onCalculate. Now that's going to fail because we actually haven't defined our calculate method in C++ yet, right? So we're going to hit that try catch, and then it's going to call onCalculate, and the result's going to be 42, I think. So no matter what we do in the calculator, it's just going to return some bogus value. So before we add the C++, let me just show you what this thing currently looks like. That is the wrong one. Calculator 1 is what I want. So you'll notice nothing's special about this. This is just using HTML. I can even zoom in on this. HTML, CSS around the corners, gradients, just a normal input. And these are all buttons. So I can type 5 + 5. And when I press equals, it's going to say, as expected, 42, I think. Cool. So we have a calculator that's completely broken. So obviously now what we need to do is get to the meat of this and add actually some C++ that our native client stuff. So the first thing we can do is create this calculator object and initialize some methods. So these are the methods that we're exposing in JavaScript. So you can see the bridge at the bottom there, bridge add method name and calculate. That is how we're adding our calculate method in JavaScript to our C++, so it recognizes it. We'll create up a callback function, and this callback function is a reference to the the JavaScript on calculate method that we're passing in our JavaScript. And that'll take the bridging layer as an argument. It'll take our expression, and then the return value will be set by this sort of C++ calculator, this calculate method. So just to remind you, back in our JavaScript, right, in the front of this application, we have that calculator module.calculate that takes the expression, and that on callback in JavaScript is that in callback also in C++. So back to C++, we're creating our Nexi module. There's far too many fancy animations in this slide deck. But the bulk of this is not that interesting, actually. So there's this first evaluate expression part, and that's going to take that postfix expression, the input, and just create an array based on it. The last thing we do when we calculate this, and 5 plus 5 in C++, that's not too difficult, right? But again, this is just demonstrating the sort of different layering here. The last thing we do in this method is called the Pepper APIs, which is npm invoke default. We'll pass it the function, the object that we get back, the actual value to our C++, or excuse me, our JavaScript method on callback. So if that makes zero sense to you, basically what it means is that we just called the onCalculate method in JavaScript from C++. And this time, hopefully, the result will be passed. C++ will have done the calculation for us, 5 plus 5, and then hopefully there'll be no errors, and we'll just set the formula.value on that text to the result. So let's see what that looks like. By the way, I've already pre-compiled all these modules. So you can see in this case, right, the first demo, the Calculator 1, just had the UI. There was no native client module tied to it at all. In this case, we actually have the module loaded, right? The embed tag is there, so we're just alerting that the module is finished loading in this case. So hopefully, if we've done everything right, if I type 5 plus 5 in now, we'll get 10. So that's cool, right? That is JavaScript talking to C++, C++ doing the calculation for us, and then throwing that back to JavaScript. And just to prove to you that this does work, we can do more complex. 45. Cool. So it does work. You take this one step further. I don't actually have the code to show this to you. Whoops. Did I mention it was still somewhat of an experimental technology? Do we have a sound? Can you guys hear that? Okay. Can you hear the button clicks? Does it work? I can't hear it down here. But basically what's happening here is we're sampling sound in C++. And we're taking the JavaScript events, we're processing the clicks, and then the C++ is rendering and displaying or processing that audio when I click a button. There we go. I can hear it. Who knows the answer to this? That's what I thought. Okay. So that is sort of the anatomy of a native client module, a native client application. Before I show you some other demos, I'll just sort of finish up the slides here. Coming attractions. So at this point, we're sort of we're still building this out for developers. This is sort of an evolving technology. We do have full debugger support with GDB, but nobody wants to debug in GDB anymore. We have better tools. We have things like Visual Studio. We have IDEs like Eclipse and Xcode, right? So we're going to start to work with it's actually an open source project, right? So we're going to start to work with developers and internally to develop some of these things. So we actually have an implementation of Visual Studio compiling and debugging a native client module, which is really cool because you get all the fanciness of the IDEs. The last point I want to mention here is a project, a similar project called Portable Native Client. And what Portable Native Client is a way, you remember you saw the different modules compiled for the different architectures, so 32-bit, 64-bit, and ARM. PNACL, or Portable NACL, is a way to combine all those into one. So you can basically you write your code once, and it's ported over across all architectures. So that's a pretty cool idea, at least in the C++ world. So a summary of sort of what you saw here today. Basically what Native Client is, it's a way to run native performance C++ in the browser using Google Chrome. And what that opens up is a choice of language. So you can run C, you can run C++, you can use libraries you have, you can port a desktop application, but you can also do assembly. You can also run Objective-C or Python, right? Those are all based on C. And we actually have an implementation of Python running inside of Native Client, which is really, I don't know about you guys, but Python is my favorite language, and that's pretty exciting. So you can take full power and advantage of the client CPU. You maintain browser neutrality, right? You get all the properties of the web inside of a native client. And you provide a safe sort of execution space for web apps. So a couple resources. This is the top one here is the project page itself. This is native client, the source code. But if you're actually developing an application or interested in developing an application in native client, you should take a look at the Google Code project for the native client SDK. And that's good. A getting started guide. It's got samples. It's got the tool chain. It's got everything. So that should get you started. The last link here is just sort of an overview of the technology and on chromium.org. This is the sort of Teams project page. How much time do I have? Like a minute? 1 minute? All right, I'll show you a few more demos just to get your minds thinking about what some of this stuff can do. Granted, these are sort of sample demos. So here's an example, if it loads, of using Qt in native client.